2-3, and you should be on page 8 of your packet. And what we're going to do today is some long division with polynomials. Here's what we've got. It's called the division algorithm. If you have a function f of x, let's say that function is x squared plus 3x plus 2. Well, we know that this polynomial can be divided up into parts. It can be multiplied, these parts can be multiplied together, such as x plus 2, x plus 1. And in this case, since both of these expressions actually FOIL and make the original polynomial here, f of x, then there would be no remainder, so plus a remainder of 0. Well, that doesn't always happen whenever we are dividing polynomials. So sometimes you might have a remainder here. But basically, here's what we've got. You've got the f of x. This would be in long division. This would be your dividend. The dividend is what goes underneath the division bar. Okay, so this is where your f of x would go, your actual function. And then your divisor, your d of x, that's what you're dividing by. And the q of x would be the quotient. So your d of x goes on the outside, that's your divisor. And your quotient, q of x, will go on top. And then if you have any remainders here, that would go on the end, r of x. But that's kind of the setup of it. You can basically take this expression here and you divide everything by d of x, which is showing you what you're doing. You're dividing by. That's becoming the divisor. And when you do that here, you have left your quotient plus your remainder, and your remainder would be d of x. Remainder would be over d of x. All right, that's just a lot of work with symbols. Let's go ahead and look at a couple examples. But before applying the algorithm, there's some things that you want to make sure that you do. Number one would be to write all the parts in descending order by powers. You need to put it in order, a polynomial order. And the second step would be if for some reason you're missing any exponents, that you would need to include some zero coefficients for those missing powers. So if you're missing an x squared, make sure you include 0x squared. You have to show each placeholder for our exponents. All right, here's what we've got. We're going to divide 2x to the fourth, this expression right here, by x squared plus 2x minus 3. So this is my function, and this is my divisor. This is d of x then. So the algorithm would tell us that we can put the x squared plus 2x minus 3 as my divisor, and 2x to the fourth plus 4x to the third minus 5x squared. Actually, all of my exponents are in decreasing order here, and I've got 3x and then minus 2 as my constant. All right, we don't need to insert any expressions here. We've got x squared and then an x and a constant, and then our powers decrease here with my original function as well. So it's ready to go. All right, here's what we've got. You're going to ask yourself, what's 2x to the fourth divided by x squared? And whatever that result is, so you're taking the very first expression and you're dividing it by the divisor's first expression. And that result is a 2x squared. And that's what you write on top, 2x squared. And then you will multiply everything back through. So you take the 2x squared times all 3 of these terms. And you will write them below their like terms here. So we've got 2x to the fourth plus 4x squared, x squared times x, x to the third, and then minus 6x squared. And just in long division, what we do here is we subtract. So 2x to the fourth minus, those cancel. 4x to the third minus 4x to the third cancels. Negative 5x squared minus a negative, minus a negative, which would become plus a positive, so x squared. Okay, now after you have your division and then you subtract, you will now bring down your next term. And since I'm dividing with a trinomial, you'll bring down both of these terms so that you have another trinomial that you're going to divide. All right, we're ready for the next division, and now what we're going to do is we're going to take x squared and divide it by, again, the first expression. So x squared divided by x squared, this would be plus 1. So we have plus 1 here, and distribute all of that down. So you take 1 times all 3 parts, you get x squared plus 2x minus 3, and now we're subtracting. X squared minus x squared is 0. 3x minus 2x is x, and negative 2 minus a negative is plus 1. Okay, we are done. We don't have any other parts to bring down. And so since this x is a smaller exponent than x squared, we're done dividing. Here's our final answer. So we've got our quotient of 2x squared plus 1 plus our remainder, and our remainder is x plus 1 over what you divide, the divisor, x squared plus 2x minus 3. So here's my answer. That's long division. All right, let's try another one. We've got x to the third minus 1 here. This is my f of x, and we're dividing by x minus 1, which is my d of x. I put my d of x on the outside, and on the inside I put my x to the third. I have to insert a 0x squared. Got to do the placeholders, and then a 0x as well, and then minus 1. Now we're ready to divide. So you ask yourself, x to the third divided by x, that's x squared. So you're doing x to the third divided by x. That gives you your first expression. Now you multiply down, you distribute, so it's x to the third minus x squared. Now we're subtracting. Those cancel. When you subtract, you add the opposite, so that's x squared. You bring down your term of 0x, and I've got 2 terms here, 2 terms that match the outside, so I'm ready to divide. I do x squared divided by x. You only look at that very first term when you're dividing. All right, that would give us plus x, and distribute down. So we've got x squared minus x, subtract. X squared minus x squared is 0. Add the opposite here. You got x, and bring down the minus 1. One more time, dividing. X divided by x is plus 1. You can see it's exactly the same expression. You get x minus 1. So when you subtract, you get 0. All right, that 0 means no remainder. And when you don't have a remainder, we're also indicating that this happens to be a factor of. So my final answer is x to the second plus x plus 1. That is the quotient. This is q of x. Now, and like all other things in math, there's always a better way, a quicker way, so that we don't have to use all these variables here, all these exponents. And I'm going to show you that now. It's called synthetic division. Okay, if this is my f of x and this is my d of x, well, what I can do is, if I just figure out, if you set your divisor x minus k, set it equal to 0, and solve for x, you'd get x is equal to k. Okay, I need this number k. This k is part of my synthetic division. It goes on the outside of my dividing. We do the division a little different than we did long division. So this is kind of like my synthetic division bar. And then what I do is I'm going to pull out all of these coefficients, A, B, and C. And again, they have to be in decreasing order. So if you're missing an exponent, you're going to insert a 0. So A goes here, B, and then C. And here's how synthetic division will work. You bring down your first term. It's just you drop it down. It's A. You'll multiply the number on the bottom times K. This is multiplication. So that's AK. You will add these terms. So straight now you are adding B plus AK. And then you multiply again by that K. So it's K times B plus AK. Obviously these will be numbers. And when they're numbers, it'll be just real quick mathematical operations. And then finally this C plus whatever we get here is going to be your remainder. All right, so this expression right here is your remainder. So this will be your R of X. And the expression at the bottom here will give you the coefficients for your Q of X. All right, so but let's do a problem or two so that you can really see it work with the numbers and not our symbols. All right, there's 3 applications for it. The first one is divide polynomials to determine if the remainder is 0. Okay, so you can divide. If you get a remainder of 0, that tells us that what we are dividing by, the x minus k, whatever that is an expression that represents a solution. It helps to determine if an expression is a factor, so is it a factor of it, and it also helps in evaluating. So like finding f of 5, you know, it will give you your output if you want to use synthetic division. So there's 3 real applications for this synthetic division. Here we go. So we're dividing by x plus 3. You said x plus 3 equal to 0. X equals -3. The -3 goes on the outside. All right, so we've taken care of the divisor. Now the numbers in front here will go in my division. So I've got the coefficient of 1. I'm missing an x to the third, so 0. Minus 10, -2, and my constant of 4. All right, really, if you want to just treat all of the vertical operations, these vertical operations here are always addition. These are always addition. So 1 plus nothing, so you bring down the 1. Multiply 1 times the -3, -3. You add -3, multiply 9, add -1, multiply. All of these are multiplying times that outside number, and then you write the product underneath the next number. So 3, add, you get 1, multiply, -3, add. When you add these together here at the end, this 1 is my remainder. Now here's how you can write your final answer. All right. We've divided by an x to the 4th. We've divided it by an x to the 1st. So my power is decreased by 1. So the final answer is x to the 3rd. These are our coefficients. The 1x to the 3rd minus 3x to the 2nd coefficient minus 1x, so x, and then plus 1. Plus your remainder of 1 over what you divided by, x plus 3. There we go. This is my answer. The other things that we can conclude here. X plus 3 is not a factor because I don't have a remainder of 0. Okay, so it's not a solution to it. Let's try the next one here. Evaluate. So another type of method that we're gonna look at. If we're just simply evaluating, if you put -2 in, you know, the question is, what is the output? Well, sometimes it's a lot more difficult to put our values in, but it's very quick if we set up the synthetic division. So -2, that simply goes on the outside. That's what x is equal to. You have your coefficient 3, 8, I'm going in order, 5, and -7. You drop your 3, so this is addition here, going vertical. So 3 multiply -6, add 2, multiply -4, add 1, multiply -2, add -9. All right, here's what we got. That is our output. So if you evaluate the function at -2, we get an answer of -9. It's an ordered pair, -2, -9. That's another application for it. All right, show that x minus 2 is a factor and that x plus 3 is a factor of this polynomial, and then find the remaining factors. This is how neat the synthetic division really works here. If this is my original expression, 2, 7, -4, I'm not missing any coefficients. I'm going to show you that x minus 2 is a factor, so I put 2 on the outside. I put the solution to it in. Bring down the 2, multiply 4, add, you get 11. Multiply, you get 22. Add these together, I get 18. Multiply, 36. If I add these together, I get 9. Multiply, I get 18, and add, you get 0. Okay, now what this shows, since I got a remainder of 0, then x minus 2 is a factor. All right, if I'm trying to show x plus 3 is also a factor, I would put -3 in, but here's the neat thing, is I don't need to go back to the original. I can go right now to the reduced polynomial. You go to the smaller one. I can keep dividing by other polynomials, and that's actually what you're going to want to do. So use what you had left. You bring down the 2, multiply -6. Add, you get 5. Multiply, you get -15. Add 3, multiply -9, and add, you get 0. So this also indicates they're both factors. It wants us to find the remaining factors of 2, 5, 3. That's this expression, 2x squared plus 5x plus 3 equals our polynomial, f of x. You could ask yourself if it factors. Can I factor this? You bet. Let's factor it. If not, then we don't have any other factors. Let's see, let's do 2x here. 1. Both of the signs are addition. This is x. That makes that 3. It does add to 5x in the middle. All right, so here's our final conclusion about this problem. This problem indicates that x minus 2 is a factor, x plus 3 was a factor, and so are the ones I just found, 2x plus 3 and x plus 1. So the polynomial in completely factored form would be this. If I were to multiply all those together, I'm going to get this polynomial. All right, that concludes the synthetic division and long division for our polynomials. All right, this next problem, example 6, the last one, is a modeling question where you're going to take some information and use the calculator. What I want you to do is go ahead and go through this problem and pause the video, and we'll come back and I'll be able to give you the listed answers. Let's see what we have here. So you're going to put this into y1, and you're going to be able to see this graph here, but then what you want to do is take the information that you're given, all the ordered pairs, and your x's and y's, and put them into your lists and try to see if you can do your scatter plot and do a model of best fit. All right, here's what you've got. So you're plotting the data and graph a model in the same viewing window. Graphing is the one that is your S equals the 0.0078. That's the model that you graph. Here are the results that you get for your table in the synthetic division. All right, it says use the remainder theorem to evaluate the model. Would you use this model to predict the sales from lottery tickets in the future? You can see here that there's quite the increase from 2011 to 2018, a lot of an increase. And the reason why is because that function is an x to the third, it's a cubic, so it's going to rapidly increase. So it's probably not a very good model to use after an extended amount of time. All right, this is what you got for your assignment.